Hello, good day, viewers. In this virtual class, what we'll be looking at is how to derive the cosine rule. Here, we're going to look at a situation where you have a triangle. Um, triangle. Now, let's assume we're label it this one, and you're either looking for some of the angles, okay, or you are looking for the sides. Then the height or the altitude is not supplied. Okay, so how do you manage it? Those are the things we're going to look at in this class. Right. Now, first of all, what we will do here is that for every triangle of this nature, we have that this is angle here, the side facing it is represented with small letter A. Okay, the side facing this angle here is the line AC, is there with small letter B. Then the side facing this angle C is represented with small with A, the line AB, and small letter C. Okay, these are the first thing we must do. Then to achieve this proof before us, let us draw a line from the point A down to meet the line BC. Okay, at this point here, let's assume here, meeting point, the midpoint of the B. Okay, now if you notice that this line, the line BC, is made up of the line BD now, line and that BB, line BB plus line BC. Okay, if the whole line BC is A, so we could say here, assuming here this is A, then assuming we choose any known, let's say X, so here BD will be X plus the line BC, the line BC. So the line BC become A minus X. So here is A minus X. So remember that this triangle now, triangle ABC, is made up of two triangles, which is triangle ABD or triangle ACD. And this triangle, they are what? They are right angle at this point here. So let's assume we bring them out. We definitely bring them out. Let's bring the first one out here. Yeah, bring this out. Here is A. This part here is D. Here is B. Here is X. Here is C. And let's assume this place to be the height. Okay. Then let's also look at this other part of the other triangle, where we have A, here is D, we have the common height A, here is A minus X, here is C, this part is D. So this is where we're going to take the proof from. So just stay back and look at the procedure. Like I said, that this triangle, they are now right angle triangle. So we could, assuming we are looking for this angle B from the card, because since this triangle are now right angle, we can apply soccer twice. So we are looking at card here. That is the cosine, the ratio of the adjacent, so adjacent to that of the hypotenuse. Now, if you look at this angle here, B, the adjacent of this angle B here is the line BD, which is X, and the hypotenuse is this. Okay, the hypotenuse is line AB. So if we are saying cos of the angle B is the side here X, which is BD, by the side here AB, which is C. So now let's make some formulas. X become C, small c, cos of the angle B. So let's take note of this as equation 1. Okay, that's equation 1. Then we just go back to this triangle. Since these two triangles are right angle triangles, now we apply the Pythagoras theorem, which say that if you have a right angle triangle, the square of this hypotenuse, the side facing this right angle, okay, is equal to the square of the sum of the two other sides. So here we could say that c square from this triangle, c square is equals to s square plus a what? A square. Okay, now let's make a square, so formula a square is equal to c square minus a square. So let's assume this is equation 2. Let's take a look at this triangle as well. Let's look at this triangle. It's also a right angle triangle. So we'll use Pythagoras. So that means the hypotenuse is the line AC. So we could say that b square is equals to the square of the other two sides, which is a square plus a minus x all square. So in place of a square here, we will go back to equation 2 and substitute c square minus s square. So let's do that. B square is equals to a square now is c square minus s square. Now we're going to expand a minus s all square. If we're expanding a minus x all square, means we're having two of this form, a times a, that gives a square, a times minus s minus ax, x times a minus s times a minus ax square, minus times minus is plus, then s times s is s square. So we replace the whole of this expression with a square, right? Minus as give minus 2ax plus what? S squared. Here, this is minus s squared. We go off with plus s squared. Now, the expression here becomes b squared is equals to c squared plus a squared minus 2ax. Then we have to go back to this because we do not really need x. So the expression representing x is small letter c because of the angle b. So here we have a b squared is equals to c squared plus a squared minus 2ac cos of the angle b. So you see that we reflect this b squared plus c squared minus 2ac cos b. Similarly, if we have decided to change the whole narration too by putting a here, if we put a here now, we will see that this will become a squared is equals to b squared plus c squared minus 2 bc cos of this angle here, cos of the angle a. Then if I decided to bring c here as well, then this becomes c squared is equals to a squared plus b squared minus 2ab cos of the angle c. This is just a simple way of showing the cosine rule, especially if the triangle given does not provide the altitude here, and the angles as well, they are maybe some of them are obtuse, some of them are acute angle. You have to find if you have this angle. Say, when are you supposed to use the cosine rule? You use the cosine rule if two sides, let's assume this side is given, this side is given, and this angle here, angle A is given. Okay, so it means two sides with one included angle. Then another point you can use the cosine rule is when all the sides are given, and you have to find any of the angles. This is a simple way of showing the proofs of the cosine rule. If this video are very useful to you, like, comment, and also share on your social media platform. See you in my next question class.